we're talking about different types of symmetry, which we've been talking about since the beginning of the year, right? The first type of symmetry that we did when we were talking about the letters was bilateral symmetry, which literally, if you draw a line, which is what the lateral part stands for, and bi means what? Detuan, what's bi mean?
Two.
Huh? Two? So when you talk about bilateral symmetry, you'll have one line, and it'll be the same on both sides. It'll be two equal parts. When we're looking at radial symmetry, we're talking there, it radiates out, like the energy from the sun radiates from the sun. It goes outward, which is what these are. This is a scientific diagram, clearly. And it's one that you're going to see in biology or anatomy or something like that. They will talk about bilateral symmetry and stuff. So here's, bilateral symmetry, radial symmetry, and then asymmetry, which means there's no symmetry at all. Okay? What you're working toward is we're working along two axes. So if you have two axes, your base number of elements is going to be what? Base elements are what? D'Amica. Base element for two axis symmetry is what? You don't know. Okay, this is going to be really embarrassing then when you get to the testing portion of our program, which is basically right now. Base unit for two axes is 4. Now, and then we're moving, and the 4 you guys were supposed to turn in on Sunday, so I know everybody's got that done, but again, I'm not going to grade it until Wednesday, so you might have a minute. Now, then we're going to 3 axes, where we're going to have an X and a Y and a Z. Right? So your base unit for 3 axes is going to be what? Okay, we're going to quiz this or what? Because I need participation or we will no longer have this running this way and I just start giving pre-tests, post-tests, and mid-tests. Excellent news. So, base number for 3 axes is going to be what? If 2 is 4, 3 is going to be 6. Right. So, that's where we need to look at. Now we're going to look at some of these examples. This first one, how many axes is this on? 5 is not an option. We have 2, 3, or bilateral. Which one is this?
Bilateral.
What?
No, it's...
Is it 2 axes?
No?
No, wait.
Try again.
It's 3.
3 of them, right? Because we have 6 main elements. We have an axis right here. We have an axis that's right here. 1, 2, 3. Right? We got 3 axes, 6 base elements, which means that everything you do is going to be multiples of what?
3.
What? 6. Well, 3, yes, but the 6. So it's going to be 6, 12, blah, 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 blah. I don't think we ever really
Blah,
just
blah,
get
blah.
3. Blah, blah, blah. All right, so that one's 3 axes, okay? Then the next one we have is this one, which is how many axes is this on?
2.
Huh?
2.
2, right, 2. We have the X and the Y, all right? This is an actual geometry test. They will show you, Ms. Miner and I sat down last year, and she was showing me this, and I'm like, oh, and one of my kids scored the highest on that test because they knew what they were looking for. This is 2 axes, right? The next one. Is this bilateral, radial, or asymmetrical?
Asymmetrical.
Why?
Because it don't really have a base to say.
It's not a 2 axes or a 3 axes. This one is running off a unit of 5s, which I'm not even sure that happens in the middle here. We do know we have 1, 2, 3, 4, 5, so it does have like kind of a star-ish thing going on. It is kind of radial because they did do like bam bam on each side and like this, but this does not fulfill the requirements that we need for you to turn it in, okay? So it's cool. It is radial symmetry, but it is not along 2 or 3 axes, so that did not hit the criteria to be graded in my class. Does that make sense? Now, the next one, what about this one? Bilateral or radial? I think we have bilateral working here. They did start off with a base 3 unit, which is what I was saying. Starting off with the 3 doesn't necessarily fulfill the 3 axes. So that one was weird. This one, does this fulfill our grading requirements for what we're doing?
Yeah.
How many axes?
4.
2, right, because it's got a base unit of 4. This one, how's this one?
It's the
This is a tricky one. 2 axes or 3 axes? This is radial symmetry, and we can tell that because it kind of has that, you know, Mandela round thing going on. How many axes?
I say
too many.
No, it doesn't have too many. It's pretty good. This one has 4 on it. You can see it right. The problem is if it doesn't, well, it does line up straight up and down. We can line this up. 1, 2, 3, 4. 1, 2, 3, 4. He had 8 base unit in the center around that circle. So this one is along a 2 axes. All right, the next one, there's a couple of these where it starts to get tricky. How about this one? Yeah, we can see that one, right? That one's easy. How many? 2, right? All right. After that, we have how many?
is
2.
it? Yeah, 2.
And this one?
2.
There you go. Now we're getting to the point where we can see this.
2.
2,
2.
2.
A 2.
This one's hard because it's a crappy picture, right? They didn't get over the top of it. It's not in focus. We have a hard time seeing this, so it's actually 4. Right there, 1, 2. It's got 2, so it's built on a 4 base, but it's hard to see because the picture's so crappy. We need to take better pictures. This one we can see, right? This is the start. So when you guys are working on your projects today, what I want you to do is I want you to lay it out today. I want you guys to get going where you're starting to set your base numbers. You don't have to glue it together today if you're still scared about it, but lay it out so that we can actually talk about it. This is, what is this one? 3 axes, right? Because there's a base unit of 6 in the middle. If we do that one XYZ thing going on there, we're great. So, this one's the same one. This one, how's this one?
Crappy.
The craftsmanship, which is how you roll them up and how you place them together and how you do stuff on this, is not great. But it does fulfill the requirements of being 4. Now, it doesn't have enough elements yet because how many elements are you meant to do with your 2 axes?
4.
No. How many elements total are we meant to have? No. Just with the 2 axes. So it's the base unit of 4. How many elements were we meant to have? 32. Total. 36. 36 is for the 3 axes because it's on multiples of 6, right? All right, so there's another 4, another 4. What's this one? Is this one good? What symmetry are we demonstrating here?
2.
What does 2 mean?
2. No.
Radial symmetry or bilateral symmetry?
Bilateral.
It's bilateral symmetry. I think that they were going to make it, this is supposed to be radial symmetry along 2 axes, and they just haven't put these components over here, because that would do it, but then at this point it just makes it bilateral, one single line down the middle, same on both sides. So, there's that one. This one is good, right? Do we think this one's good? I'm asking my cameraman. You recognize that?
Yeah.
All right, this one's good. Good. Again, we're back to the craftsmanship issues. What I would do with this one, since it's got those big centers in there, is if you roll up one that's really tight and small, and you pop it inside of here, it will fill in that space. Okay? That's just an aesthetic term about this because they didn't roll it very tight. This one, I don't even know. So what we need to do, you've got these going on. This one's good. This one's good. This one, this is where they start off. And once you start getting this is bilateral symmetry, right? This is not radial symmetry. We can agree on that? Because it goes up and down and it doesn't have these components over here. It started off radially symmetrical in the center portion, but then this should be over here and here if we want to make it the same on all 4 pieces. Bilateral symmetry again, because he's got those extra flowers on the end there. Okay. What is this one? This is one that actually somebody turned in yesterday. So what is this?
A C.
I don't know what this is. It looks like they started off with their 4. We got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then something gets lost up here. So what you need to do is you need to bring it back in, rein it in, and figure out what we need to do with that. Bilateral symmetry, really cute, but not what we're looking for right now. Bilateral symmetry again. This one is on 2 axes, radial symmetry, 2 axes, radial symmetry. Again, we've got something going on here where they started off, but I'm going to tell you right now, I think this is the original group or cluster. What ended up happening at that point is they had bilateral symmetry going on here because they didn't have these equally spaced. Do we see that?
Yeah.
You get what I'm saying with that? All right, so that is what we seem to be having the most problems with. Again, bilateral symmetry because they didn't get, because we had 2 placed here, 2 placed there, and it's a line that either goes through here or through here, but it doesn't do both. What ends up happening in one section will happen in the next section, will happen in the next section, will happen in the next section. Tell me I ended on a good one. Nope. All right, so what you need to understand here is whatever you do in the 4 quadrants will happen in each of the 4 quadrants. So here we have 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. And those are the elements that are going on. This is your 4th element, which will end up happening 4, 4, 4, 5, 5, 5, 5, 6, right? So now I'm getting confused. 6, that'll be this one, 6. And it's just a rotation at that point. So whatever happens here gets rotated and happens here, gets rotated and happens here, gets rotated and happens here. Do we understand where I'm going with this? We're good? Okay. So that's what I want to see you guys do. And then once you move into your 3 axes, it'll happen in 6 different places as opposed to just 4. All right? All right. Cut. Thank you.